Guess let's get started. So welcome everyone. Welcome back for another virtual science camp. This one on balancing chemical equations in the kitchen. So as you can see, I'm in a slightly different spot in my place than usual. I'm in a kitchen with some simple ingredients around like baking soda and vinegar, which will be the stars of tonight. Hopefully you guys have these materials to follow along. I'm just gonna end the poll to share the results of the, well, actually there's only a couple of people answered, but if you have the materials and if you're not shy, turn on your camera and show your materials so that we can see everyone who's ready to go on this one. Okay, and it looks like from those of you who have answered the poll, everyone's perfectly comfortable with English. The couple of people answered are indeed in the kitchen, so ready to experiment along with me. And most of you aren't that familiar with the periodic table. So anytime we use the periodic table, I'll go kind of slow with things. And there's not many of us, so feel free to stop me even more often than usual to try and explain things if there's anything I go a bit too fast on or anything like that. Okay, so to get started, the first thing I'm going to do is I'm going to show you my invisible tea, and I'll be explaining the invisible tea at the end. So I'm going to grab hot water that's been sitting on the stove. This is one for now. I'm just demonstrating for you, so you don't need to do this yourself. So I have this cup, which is slightly cloudy, but it's pretty see-through. And I'm going to take an invisible bag of tea. I'm kind of pretending here, but taking an invisible bag of tea, put it in there, and I'm just going to set this this magical tea aside in the background. And I want you guys to keep an eye on that, like you can kind of see it there. So you can see I'm not touching it or doing anything with it, and you should see the tea should infuse over the course of everything else I do. And I'll explain to you why at the end and how to make your own invisible tea like that. But now for the experiments that you guys can do along with me, the first thing we're going to do is we're going to measure out some sodium bicarbonate. So hopefully you have a kitchen scale or balance. I'll turn on my second camera probably because it'll be easier to see what I'm doing with that. It'll just take a moment for me to get my second camera turned on. Okay, it should be on there. Should be. And I'll just spotlight it so you can see it nice and big. Okay, so now you should be seeing where I have a kitchen scale here on my table. And I'm going to weigh out 50 grams of sodium bicarbonate. So what I'm going to do first is I'm going to put the plate that I'm going to use, and this is one that I'm okay putting in my oven. So hopefully you have a dish or a plate that you're okay putting in your oven. I'm going to turn on the scale first, and it takes a minute, and then it has a 0 it's reading there. If it reads something other than 0, I can always 0 it again. And I'm going to put it with the plate on there, and I'm not going to 0 it.
Wait, nothing.
Sorry, can you repeat that question? Okay, I didn't hear the question. It sounded like it might have been Gabriel who started asking and you're on mute again.
Oh, okay. Where do we put the bicarbonate?
Oh, so on top of the plate or dish that you can put in the oven.
Okay, like this.
And how much do we put?
And I can't see the plate. One of the things with using virtual backgrounds, often it clears out anything other than your face. But if it's a plate or dish that you're showing, yeah, that looks perfect. So if that'll fit on your balance and you can weigh it with that, then put it on your balance.
How much do we put in it?
50 grams. So
okay.
I'm looking at mine and my plates, and I've put a piece of baking paper just so it's easier to move off the plate, but you don't need that if you don't have one handy. Mine is 372 grams, and I'm making a note that that's the mass of the plate.
So we're doing the mass of the plate and the bicarbonate soda together or separately?
Separately, like the goal is so that you know you'll have 50 grams of bicarbonate, but in case you don't have it with the same plate afterwards, like if it's too hot afterwards and you need to move it,
How much? 30 grams?
50 grams.
Okay.
Although if you feel like using a different amount, you don't have to use the exact same amount as me. Oh, and see, that's a good reason why I wrote down the mass of the plate. My scale went off. So I'm just going to turn it back on again. And I know I'm going 50 more than 372. So my target mass will be 422.
427.
I've got it.
Okay, and once you have it, you guys seem to be a little bit faster than me. Then you want to spread it out a little bit in the dish so it's not too clumped together, and that's just so it doesn't take as long to heat. And then you'll want to put it in an oven at about 200 degrees.
For how much time?
About 15 minutes, and we'll get back to each other and like remind each other that we want to take it out in about 15 minutes because we'll do some calculations and maybe start the next experiment depending on the time for that. So you see how I've spread my pile out just so it's a little bit more exposed, not like one big clump together. And I'm just going to move this into my oven, which you can kind of see in the background, or you can just believe me, I'm putting it in the oven. You don't need to
Do we put it directly in the oven? Like if it's a plate, we put it directly in the oven?
It'll fit and not spill. If it needs to go in another container to be safe in the oven, then do that. Like I put my plate on a tray in the oven, depending what your dish looks like and how it fits. However, it can fit in the oven so that it won't spill and you'll be able to take it out.
How long do we put it in the oven for?
For 15 minutes. So
15.
if you're putting,
Okay.
yes,
Yeah.
15. And the exact amount of time doesn't matter so much as long as it's longer than 10 minutes, but like about 15 is what we're aiming for. So it's okay if it takes you a minute longer to put it in or if it's in already. It was 6:08 when I put mine in. So at about 6:23, I'm going to try and take mine out.
So at 200 degrees?
Yes, exactly, 200 degrees.
Okay,
and it's okay if your oven isn't at 200 degrees yet. It might take a couple minutes to warm up. But for this reaction, the only thing is that it needs to be hot for several minutes. So 15 minutes, that should be more than enough time. But if your oven was cold, then like that gives us a little bit of room for error. If everything was hot and the bicarbonate was really spread out, 5 minutes would be enough. And there's no risk of doing it too long. We
Is
could
it
forget
15
about it for now.
minutes is it 15 minutes if we didn't put it hot before?
If you didn't put it hot before, that's okay. It should be okay in 15 minutes. If we're not sure, we might leave it to like 20, depending on how long the other experiment takes.
I preheated my oven and I spread the bicarbonate out. So about how long?
Oh, so it should probably only take 5 minutes, but we'll still leave it to 15 because the reaction won't do too much. It'll just do like the amount it goes, and it can stay in the oven for hours and it'll be okay. It's just, it needs to be a minimum amount that it's been done. And the minimum amount, if all the ovens were hot to start with and the bicarbonate was spread really well, probably 5 minutes is enough. But just to be sure, that's why why I said 15 minutes. Does that make sense?
Yeah.
Perfect. Okay, so now we're going to look at the equation of the reaction we're expecting to happen. So we started with sodium bicarbonate, and I've switched to my other camera so you can see this paper where I have the masses. I'm just going to take another sheet of paper and write the beginning of chemical equation. So here, I'm just writing the chemical name, sodium bicarbonate. And I'm going to draw an arrow, and that arrow means there's a reaction happening. And there's a special symbol, and can you guys see this okay? Like, is it showing up or do I need to write bigger?
I can see.
I'll take that as
Inside.
okay. So when we put a triangle over an arrow, that's just a fancy symbol saying we're adding heat. And I can write heat next to that in case anyone doesn't remember that triangle means heat. And then we're going to get some kind of chemical change happening. And does anyone know in cooking, like if you add sodium bicarbonate to something, what does it normally do? Why would we add it to something that we'd cook in the oven? Has anyone ever done like baking to make cookies or make cake or anything like that?
Well, I already did cookies, but
Isn't it to make it go up and
yeah, there.
expand?
Exactly. So it makes it expand or get bigger. But it's not adding more matter because we can't get more matter from nowhere. But it's breaking down the sodium bicarbonate into a couple of different things. And one of the things takes up more space and it's a gas. You might have seen this too, like if you made volcanoes, that's a common thing, mixing vinegar and sodium bicarbonate. Any guesses what gas might be made?
Energy.
I'll give you a hint. The chemical formula for sodium bicarbonate. I'm gonna write it a little bit bigger so we see the symbols. Is Na, oh, good thing I used something I can
I can't
erase.
see the other one.
You can't see, like, can you see
No, 'cause
NaHCO3?
Because your spotlight is.
Oh, which,
So I can't see
the other people or?
No, I can't see that what you're writing because the number 1 is spotlighted.
Oh, check if it's not pinned for you because it should be, like the one where I'm writing should be spotlit, but if you pin the video, then it overrides that.
Okay.
Did that fix it?
Yeah. Thanks.
Perfect. Okay, so what we have is Na is the chemical symbol for sodium, H for hydrogen, C for carbon, O3 for oxygen, and CO3, like carbon with 3 oxygen, is called carbonate, and it's a special kind of ion. So from these kinds of atoms, are there any ones that might go into a gas we might be familiar with? Like, how about if we took carbon and we took 2 of the oxygen? Is that a gas anyone knows? Can anyone think of any gas you might have ever heard of that has the word carbon in it? I'll just go ahead and tell you. It's
Wait. O2.
Gabriel has a guess?
CO2.
Excellent, CO2. And the long name for that is carbon dioxide,
Dioxide.
which means 1 carbon and 2 oxygen. But that's not everything over here. We also have a couple other things, right? We still have some sodium, which we'll keep track of down below because just it has a bit more room. And it's hard to guess what kind of sodium compound comes out, but we have sodium carbonate left, NaCO3. And we still need to take care of the H. And we get our good friend H2O. And this isn't quite balanced yet. I'm just going to balance it kind of quickly because using it will be more useful for the reaction than getting you guys to like try and go through balancing it. So just because of the number of molecules that works out, we actually have 2 sodium bicarbonate that gives rise to 2 sodium carbonate plus 1 carbon dioxide plus 1 water. And when we just have one of it, we don't need to write 1 out ahead of time. So that's our equation for this decomposition reaction. And we call it a decomposition reaction because it's breaking down one big thing into three smaller things. And there the carbon dioxide is a gas, and the water is actually a gas as well. When our oven is at 200 degrees, that's hotter than 100. So it's going to come off as steam, and we'll be left with only sodium carbonate here. And we can use a periodic table to predict a little bit the quantities of that we should get when we put in 50 grams of sodium bicarbonate. To make those calculations a little bit easier, I made a spreadsheet so we can add up what the masses of each of the things are and try and balance the equation. So I'm going to share my screen again to show that to you. No harm done. Okay, so here, the first thing we want to do is try and figure out the mass of each molecule in the equation. So I've done water as an example. That's got the formula H2O, which means it's got 2 hydrogen and 1 oxygen. And then if we look on the periodic table, so I sent you guys a link to a periodic table for anyone who doesn't have one already. And a lot of you, if you're not that familiar with the periodic table, you probably don't have your own periodic table. So if we look on the periodic table, we see a bunch of numbers here. And hydrogen, that's number 1. And it's got a 1 up here and a 1 down here. And the 1 all the way up here, this means that each atom of it has an atomic mass of 1. So we can keep track, we have 1 there. Going back to the spreadsheet, that's what we've put, the atomic mass of hydrogen is 1. And in the formula of water, we have 2 atoms of hydrogen. H2 means 2 of the H. So the total mass of hydrogen in each molecule of water is 2. Oxygen, on the other hand, if we go to the periodic table, we find it here, element number 8, which is the one at the bottom, and its mass is 16. So we're going to fill it in the spreadsheet, or I mean, I filled it in ahead of time, and it's 16. And I put this formula so it automatically calculates it for us. Now, if we go down to the sodium bicarbonate, the element symbols, the first one in there is Na. I told you guys what that one stands for, right? Can anyone shout out or write in the chat what Na is the symbol for?
LA.
Na.
NA.
It's a symbol for sodium.
Excellent, symbol for sodium. And it's right here on the periodic table. Can anyone see what the mass is? It might be kind of small for you guys. Is it big enough you can see the number up top?
23.0.
Excellent, 23. So it's and 0.0, but we won't worry about the decimal place. We'll just put 23. Oh, I skipped ahead. I didn't write sodium is the name of that element. One of those atoms, atomic mass 23. And I have a formula just multiplying these two by each other. So far, sodium's contributed 23 to the mass of the molecule. Then we go along, the next one is H. What did H stand for? H is the chemical symbol for which element?
I don't know.
Hydrogen?
Hydrogen, which has an atomic mass. Oh, and there's one of those in NaHCO3. Atomic mass of 1, so it's only contributing 1 to the mass of that molecule. Then we get to C, and the name sodium carbonate, we can take a pretty good guess that's for carbon. There's only one of those, and let's look back to the periodic table. Here's carbon. What's the atomic mass?
12.
12, excellent, thank you. 12, and O, that's for oxygen. We saw that above with water. We have 3 of it here, because it comes after the O, and it should be smaller, but in spreadsheets, you can't make like the smaller number below. The atomic mass is 16. We saw that above. And so the total mass of one molecule of sodium bicarbonate is 84. And we're going to use that when balancing the equation in a moment. But it's 6:23, so that's time for me to take my sodium bicarbonate out of the oven to let it cool for a couple minutes. So I'm going to go grab it. Please do the same for yours so that it has several minutes to cool, because we don't want to be touching it when it's hot.
Wait, Italian flame. 2.
And once you're back, we're going to go through the exact same thing with the sodium carbonate. So we have all the elements from before. Here we have sodium again. And I'll go kind of quick because we've seen these before. We're just copying the information we saw on the other side of the table. Here, there's 2 atoms of sodium. Atomic mass is still 23. That hasn't changed. So it's contributing 46 to the atomic mass of sodium carbonate. We have carbon, which we saw before as well. There's only 1 of them in sodium carbonate. Atomic mass still 12, just like we saw on the other side. So it's contributing 12 to the mass of the molecule of sodium carbonate. Then we have oxygen. We have 3 of them again. Atomic mass is still 16. So the mass of 1 atom of sodium carbonate should be 106. Now that's going to be useful when we try and balance the equation and predict what the mass should be after the decomposition reaction. So I've got a second tab to the spreadsheet. And this seems like a lot of numbers, maybe, if you're not familiar with the periodic table. This stuff is kind of high level. If you're having so these are the 2 numbers we're going to use in the decomposition reaction. The mass of 1 molecule of sodium bicarbonate is 84, and of sodium carbonate is 106. For the decomposition reaction then, molecular mass 84. Here we have 106. I'll probably just give you the 2 others rather than taking the time to go through them. But if you wanted to do it for yourself, you'd go back to the same molecular mass calculations and do the same thing. Oh, I did it for water, for an example. And carbon dioxide, it's 44. It works out to 44. And there's some questions in the chat. Sorry, I didn't see them before. The carbonate looks just the same. Excellent. That's a very good point. So there's no color change, and it'll only be the mass that's different. So don't touch it yet. We can leave it to cool. We can wait. We can weigh the mass right at the very end. That's one of the reasons why I'm distracting with the calculations. But the product that should make sodium carbonate is also a white powder, but we should have less mass of it. So if we compare the potential yield, so getting back to this spreadsheet here, we have 2 molecules of it. So this should actually, so we took 50 grams of sodium bicarbonate, and then this number here, number of moles, that's going to be a new term unless you've done Catrium level chemistry. But that just means the number of molecules, like on a big scale of molecules. A mole is the amount of atoms we need for 1 gram to correspond to 1 atomic mass unit. So like it's a fancy number that makes mass work out. So here, this corresponds to 0.6 moles. And when we balance the equation, I should have included the number up here. I don't know why I didn't have that before, but that's actually 2 of these. Because when we balanced the equation, we had 2. And so, sorry, I confused myself. If we look back at my second camera, it's 2 of sodium bicarbonate and 1 of the other. So we should expect half as many moles on this side. That is, for every 2 molecules of sodium bicarbonate, we get 1 molecule of sodium carbonate with the balanced reaction. So here, we're just taking half of the number of moles. So 0.3 from the 0.2 on that side. And we're predicting we should have 31.8 grams. I think it's probably still a little bit hot to test, so we'll do the decomposition reaction before we take the mass of it, because it's quite quick to measure the mass of something. So I'm going to stop sharing my screen. I'm going to spotlight my front on camera again, so you should be able to see me. Notice in the background, my invisible T. We're starting to get a little bit of color in the bottom. Not much, so we're going to leave that for another minute. We'll see that right at the end and see if that color gets any darker. The next one the next equation we're going to look at is the neutralization reaction. So we're going to take sodium bicarbonate again and vinegar this time. And sodium bicarbonate is a base and vinegar is an acid. You guys have probably seen this reaction before, but probably not measured it before. So I'm going to suggest you do this either in a cup that's like a fairly big cup or a bowl, just because it'll make a lot of gas and it could make a mess if you use a tiny cup. So like a big cup or a small bowl. And we're going to use less sodium bicarbonate this time, just because we don't want to use like a whole ton of vinegar. So I'm turning my balance on again. I'll switch to my second camera. So spotlighting that one. And here, my bowl is 590 grams. So it'll be an even 600 grams once I have the sodium bicarbonate in it. So bowl only 590 grams. Sodium bicarbonate. We have 10 grams. So we're looking for a total of 600 grams. And adjust for whatever your cup or bowl.
How much bicarbonate soda do we need?
10 grams.
10, okay.
So for me, that was just like 1 big teaspoon.
How many grams of sodium bicarbonate do we have to put?
10 grams.
Okay.
And when I tested this myself, at first I tested with 50 because I didn't do any of the calculations first. And I ended up needing to use a lot of vinegar. So you'll see I have like this 1 mostly empty bottle of vinegar. And that was because I used too much sodium bicarbonate. So it's better to use 10. And if you use 10, you can fit it in a cup. It's just my cup, I don't have that many cups that are clear, and I'm having my invisible tea in my other clear cup. So once you have 10 grams in the bowl, you just need to slowly
open.
You just need to slowly add vinegar, especially if your cup's kind of small, because it's going to bubble a lot, especially at first. So just add it so it won't spill over the top.
How much vinegar do we need?
So the amount of vinegar, add it fairly slowly, and we're going to add it until it stops bubbling. And when it stops bubbling, that'll tell us it's used up all of the sodium bicarbonate. You might want to start with a spoon to make sure it's going, but because we've recorded the mass, we'll know the exact mass of vinegar we've added and the mass that it requires for it to stop bubbling. So I don't know how well it turns out on camera, but like if you're looking, you'll see I'm just giving it a little squirt at a time and waiting for it to fizz. And this is going to go on for like a minute or two, maybe several minutes if I'm really slow. And one thing to notice when you do this, and you might not have done this if you've reacted baking soda and vinegar before, but if you feel the cup or the bowl, it should feel quite cold to the touch. And this is an example of something called an endothermic reaction, which is a fancy word meaning it absorbs heat. And once you get into more chemistry, like once you start doing lycée level chemistry, you'll find that most neutralization reactions are actually exothermic and they give off a lot of heat. And that's something very particular about this one, that it actually absorbs heat and gets colder.
Is it okay if I don't use vinegar until it stops bubbling? Because my mum doesn't want me to use it all up.
Sure. Yeah, no. If you don't have enough, like if you don't have lots of vinegar, for 10 grams, it'll take about 150 milliliters of vinegar. If you want to use less, you could start over with only 5 grams of bicarbonate, or you could just look at my results and you don't need to go till yours stops. So like kind of whatever makes sense for you. And we can see it foams for a surprisingly long time. Like this has taken a lot of vinegar. And I'm just gonna turn my balance on again so we can see how much it takes. So now I'm already at 724 grams. So I've added like 120 grams of vinegar. I should only need to add about 30 more until it stops, if my calculations are right. And I'll just leave that until it stops foaming. It'll probably take like another minute or two. But once it completely stops foaming, I'll try adding a small amount more vinegar to see if there's even more bicarbonate left unreacted. Here in my case, it's a lot calmer now. So we can see it's still slowly bubbling, especially when I stir it a little bit, but it's not bubbling nearly as much as before. And probably if I leave it for a minute or two, it'll stop bubbling. So I think I've added just about the right amount of vinegar to react with all the sodium bicarbonate there. So here, my balance is reading, and I don't know if it shows up on camera, but it's reading 769. Which means, because my bowl and bicarbonate together were weighing 600 grams, that I've added about 169 grams worth of vinegar. Now there's a couple of approximations here because we've lost the carbon dioxide gas, so we're not taking into account to that, but that'll be fairly small compared to the mass of vinegar that was added. So like that is a source of error we could correct for if we wanted to do a more detailed procedure, but it's like, I consider it a perfectly acceptable source of error in this case. Okay, so I'll switch back to my main camera again, and actually I'll switch to sharing the screen so that we can balance that equation. And I'll probably just do a quick run through with it, partly because it's a bit complicated, and like spending a while on it probably won't benefit that many of you that much. But if you're really interested in this and you look over it in more detail afterwards and you have any questions, please let me know. Okay, so we need the molecular mass for acetic acid. We go back to the molecular mass calculations. the formula for acetic acid is a bit of a mess. The reason why it's almost always written like that has to do with the structure of carboxylic acids, because that's well beyond what I want any of you guys to know. I've rewritten it just with the totals of the atoms. So we have carbon, hydrogen, hydrogen. Oh, I wrote it there instead of here. Hydrogen, symbol A, symbol H, and oxygen. And we have 2, 4, and 2 molecular masses. We've seen these before, so I'm just running through this really quickly. The molecular mass is 60. We bring this back into our equation. So molecular mass 60 there, carbon dioxide, we don't really need to know that, it's 44 and water's 18. But we're mainly looking at like this much, how much, oh, sorry, that one there. How much of this needs to react, like how much vinegar needs to react with how much bicarbonate? And because it's 1 molecule per 1 molecule, we have the same number of moles. So this is going to be 0.6 mole, 10 grams here. So 0.12 moles. And then the volume that we needed to use, in this case, I had 169 grams, so that was 0.169 liters. Okay. And mine was a concentration of 8%. Yours, and you can find this on most bottles of vinegar, like usually in France, it'd be 7 or 8% if you have white vinegar. If you were using wine vinegar, maybe it'll be 6 or 7, but it'll be labeled on the bottle. So if we calculate those two multiplied by each other, so I'll tell the spreadsheet to do that. I'll say it's equal to this volume 1 times this concentration. And we should, okay, number of milliliters, not number of liters. The decimal place was in the wrong place. So we should be having 13 grams of acetic acid that reacted. And that's how those parts of that equation balanced. We could use that to predict the yields on the other side, but probably I think because some of the equations, like if I'm not mistaken, it's getting a bit complicated for you guys. So I might leave it off there and we'll just go and check the mass to see if our yield was right for the decomposition. If you're not okay with that and you want to ask more questions about the neutralization, let me know. But I'm thinking probably it's complicated enough. It's not worth insisting on that. But again, let me know if you do have questions on that. By now, hopefully, the bicarbonate we put in the oven should have cooled. So I'm going to weigh mine, and I'm hoping that this prediction of a yield of about 32 grams, like 31.8, I'm hoping I'll get close to that. If the reaction hasn't been absolutely complete, I might be 1 or 2 grams high, but I want you guys to check that as well. Be careful if things are still hot. Use oven mitts or transfer to a different plate if necessary. In this case, my balance is reading 407 grams.
Before for me it was 679 grams, and now it's 675.
Okay, so it only went down by 4 grams. Is that correct?
Yeah.
Huh. We would expect it to go down by more. Like mine went down by 15 grams, And if we do the math between 407 minus 372, then that equals 35 grams, which is only slightly higher.
Mine went down by 5 grams.
Yours went down by 5? Okay, so what I'd suggest is if you have time to play around with it more afterwards, put it back in the oven for like an extra maybe 10 minutes, 15 minutes. Because what can happen is if the reaction only went through partly, some of it will have changed to sodium carbonate, but some will still be sodium bicarbonate. So you won't get all the mass loss that we expected. Mine, this 35 is just barely over 32. So like I'm happy with that. And I'm not going to put mine back in the oven. But if your mass didn't go down as much as it should have, then just check if it went completely. Because if it, I don't know, maybe how the pile was shaped, or if it was on a thick dish, so the dish might have taken a while to heat up, you can get the reaction going a bit further. So like depending if your parents need the oven for something soon, don't insist that you need to do it in the name of science. But if you are interested in getting it lower, you should be able to get it down pretty close to that 32 gram limit. Does that make sense for that?
Yes.
Perfect. Okay, checking in on my invisible tea bag tea. I'm gonna hold it with a white background behind it because I'm noticing you guys might not see the color so much. Just gonna start with a spoon. There we go. It's got like this kind of
Purple. It's
purple
all
finish to
purple.
it, right?
Yeah.
Okay, and I'm realizing I've gone over time. To show you guys how to do this, it'll take about 2 more minutes. So if anyone wants to stay for 2 more minutes to show you how to make this, then I'll talk you through this. If you need to go because we've gone over time, then thanks for joining me and have a good rest of the evening. And I'll show that. I'll show it in hopes that some of you are interested in how I made this. So I'm just going to dump this out. So I start with a fresh, clean glass of water. So this is plain water. And I'm going to add a little bit of cornstarch. So here, just Maizena, which is like the leading brand for cornstarch in France. I'm just going to angle this camera down because I think it'll look better from this way. And I'm going to add a small amount. So this is like a small teaspoon and a quarter full. If you put more, that's okay. It's just, it'll look a bit cloudier at the beginning. And you remember when I started, mine was a little cloudy, but not that cloudy. So the less you have, the less cloudy it looks. You see here, this looks slightly cloudy. And I'm taking betadine, like it's just an iodine solution you get at the pharmacy. And a couple drops in that start a brownish color. But as I start around, it gets to this like bluish black color. And it gets that darker color because iodine reacts with the starch and becomes darker. But it actually is a thermal dependent reaction. And the reaction making it that color is exothermic, which means it gives off heat. I can't feel it being hot, but if I heat up the container, that'll fuel the reverse reaction so it'll become clear. So if I heat this up, and I'm gonna stick it in my microwave and I'll say goodbye to you guys, but anyone trying this at home, you can do this yourself and you'll see it'll get clear once it gets above about 80 degrees Celsius.
How much betadine do we put?
It's not an exact measure, just like a couple of drops till it looks dark.
Okay.
And like if you put tons and tons, you'll need to make it hotter to go clear.
So this is my my glass of well.
Oh, that looks like a perfect amount of darkness. So don't.
How long do I put it in the microwave for?
So I put mine in for a minute, and
Okay.
it's just, it depends the amount of water you have, but it needs to get to around 80 degrees. So hot enough it'll be giving some steam, but it doesn't need to fully boil. it depends a little bit how much betadine and maizena you put in. Like if you put a lot in, you might need to get it up to boiling. But if you only put a little bit in, maybe even 60 degrees is enough.
I'm microwaving my glass right now.
Oh, excellent. And you can see mine's come out of the microwave. And now, except for being a little bit cloudy, it's gone clear. Like it's lost that like blackish color. And if I leave it to cool, and you guys saw over the course of 40 minutes or so, it became faintly purple. And if I left it for even longer, like an hour, then it would become that dark, like almost black color it was to begin with. And then I can heat it again to get rid of the color. Yeah, it's not a good idea to drink it. So it's like, it's not real tea, don't drink it. Iodine in large quantities is toxic. You use it to disinfect things because it kills living things. But if not much gets absorbed by you, like small amounts, your body actually needs. But don't consume betadine. That'd be way too much, more than you need. So like, don't drink this tea. Okay,
Can we put it in the microwave?
I put it in the microwave so you can see it's steaming. And
For
it's
how much
warm.
time?
My glass boiled, and so it spilled a bit on the microwave. But it's fine. But now it's boiled, and at the bottom it's sort of blacky purple. Just a thin layer at the bottom, but the rest is cloudy.
Okay. So if there's a little bit left at the bottom, then what you can do is you can pour out the clear part into another glass, and that part will be clear for now, but it'll get darker when it cools. Like if you want to be rid of the dark part.
This is my
how much-
glass.
How much
Okay,
time
yeah,
do we
yeah.
keep it in the? How much time do we keep it in the microwave?
So it depends how much water you had and how powerful your microwave is. Like here, this is about 150 milliliters of water, and my microwave is an 800-watt microwave. So at a minute, it got it so it's like quite steaming hot. It's probably about 90 degrees.
I just was trying to mix it, and at the bottom I literally have gel stuff. The black thing is a layer of gel betadine thing.
Okay, I think probably would have been better to have less maizena. Like it's really only part of a spoon or like a big pinch that you need. But if you have like a full spoonful, then yeah, it might make a sludge that forms at the bottom of it. So you can try it again and play around with different quantities. Okay, are there other questions people have? Doesn't sound like there's more questions. Interrupt me if there are. But hopefully this was interesting for you guys. I think for a lot of you guys, bringing in the periodic table and balancing equations, that was probably the first time a lot of you guys did that. And it's a pretty cool skill to be learning this young. So even if it seemed a bit complicated at times, I think you guys did really well following along. Hopefully it was interesting for you guys. Feel free to let me know if you have any other questions, either now or if they come up and you're interested about it, let me know.
Thanks. I gotta go. Bye. Thanks a lot.
Have a great evening. Thanks for joining.
Thank you.
I think a lot of people need to go, so I'm going to say goodbye to everyone. Have a great evening. Thanks for joining again.
Bye.